Welcome to this presentation. In this presentation, I will define what a relational database is. Just mostly what a relational database is and a little bit of the features. That's all I will tell here. And my target audience is just the very beginners who are not a programmer or have extensive IT background. No, if you are just starting in IT or programming, software development or database development, so that's the target audience. Okay, yeah, that's what I will do. I will define what relational database is. I will try to give some examples and also mention some commercial products, and yeah, and also the ACID properties. I will define that. And if you watch this video, for sure you will get a basic understanding, just fundamental understanding of relational database and why you need to use one. Okay, and if you think that anyone will be will find this information useful, feel free to share this information to them. And this is Said from Toronto, Ontario, Canada. So what is a relational database? You can read the screen and the PowerPoint slide. I will try to explain in my way. So you can see two terms here. One is database and another is relational. Database is the main concept and the type of the database is the relational. So database, what does it mean? Database means just a storage of information or storage of data, where you keep database is somewhere where you keep different information, different data. So what kind of information? It can be name, address, bank account number, Facebook ID. So all those are information about different companies, their products. It depends on the context, right? And the storage, yes, we are talking about computers, so for sure we will be storing the data in computers, hard drives and all those things. But I think in very loose sense, informal sense, I think if you store data in the regular papers, diaries, notes, that can act like a database. And one other aspect is you just a database, it has to be storage of data for sure, but the data, it also has to be organized, structured in such a way so that it's easier to work with, it's easier to find the data, search the data, sort the data, or also if you want to do some calculation on the data. So database, I would not say database has to have these features, but if you are talking about the commercial databases or computer-based databases, they will give you some extra feature. That definitely becomes part of database at one point, database management system. Anyway, and relational means that the data that you will store in an organized way. And for this organization, the structure that you will use, or if you divide the data or keep the data in different places, you probably have to keep relationships so that it's easier to find, relate one data to another, rather than keeping data or replicating data here and there all the time wherever it is required. But you can organize in a different one type of data here, another type of data there, and probably some relation between this data and that data. I think I will be exploring more or explaining more on this in the subsequent places. So I will still define some more on database, probably database in without the computers, or where there is no internet yet or no computer yet. So do they still can have some sort of database, or does it still make sense, or not, or if there is any concept of relational there or not, or yeah, that probably will give you some examples and explanation on that as well. So as we are saying, database you have to keep it in an organized way for sure and easy to retrieve. And database it can exist even in computerless businesses. Yeah, in some parts of the world, probably in Africa or probably in developing countries, in rural areas, they don't use computer to keep their information there in banking or in shops or in other businesses, but still they some sort of maintain some sort of data storage and they try to work with it. Like a shop can keep all their data in paper diaries or paper notepads. A bank can keep all information in paper ledgers. So how can they organize this data? Yeah, I think what they could do, if they wanted to do it in a not organized format, they could take a big piece of paper and whatever information they need to keep they can just write here and there. So all the pages here and there they can use for shop customer data, product data, or customer purchase data, order data, sales data, shipping data, everything as they come, or probably in one row they can try to put as much information as possible, and probably one row may mean product data, another row mean customer data, another row maybe shipping and sorting data. They probably could keep it in a very disorganized format here and there, and still they probably could find out the data they are looking for and to work with it, but it would be difficult to find out and they have to look all around, and probably they have to scan, and but when the data will get bigger, so they will be in trouble. But they could use a little bit better approach, like keeping product categories in one file, one ledger, and product information in another, product purchase information, transaction information in another, and keep customer data in another file. So that's they can put some organization there, and probably let's say in product purchases they probably can just see the date and the product purchase ID, quantity, price, total price, commission, tax, those kind of information they can keep in product purchases, but they don't need to keep the detailed product information or detailed customer information. They can have in different files or different notebooks. But in product purchases they can just keep product ID and customer ID. With this product ID they can go to the product information file and then can find out the product information, or they can use the customer ID from product purchases data and go to the customer data file, the ledger notebook, and could find out the customer information if they required it. So we can say, I think even without computer people could organize information, different domains of data in different places, and then they could just relate data to each other. So yeah, still that can be sort of database, and there are some relational context there as well. And in computer systems, let's say we're not talking about the relational database management, so that's the recent business as usual. You're not talking about any software. If you're just given some text file, yeah, I think the way we kept information in our previous slide, I think the notebooks, ledger, paper, diaries, we can treat the text files like that way. So we could organize data in that way. One text file for customer, another text file for products, another text file for categories, another text file for product purchases, another text file for customer information. So that is kind of data in an organized way, and then relating data one file to another, and it probably is not giving you the searching first facility in a better way. But we can also think about Excel, one Excel book that we can consider as a database. An individual worksheet can have individual domain data, one worksheet for customer, another worksheet for product, and we can also maintain the product ID, customer ID to refer to the rows or data in one another worksheets. That also can work sort of a relational database in a pretty loose sense. So yeah, you can see, and if we open Excel, we know what the data row and column wise data means, how to keep the data and show the data in a row and column wise. Anyway, relational, I think we already have told about it. So data is stored in different files, need to be related. Product ID, customer ID, you already know. Relationship among the data are maintained. Anyway, so what are the software that gives us this facility, keeping data in different files or different domain data in different places? Actually, a relational database management system like Microsoft Access, SQL Server, Oracle, they give you, I think each file in our previous example we can consider as a table. You can consider one Excel sheet where the data are kept in row wise and column wise, the way field name and the corresponding data. So row and column wise, they store the data in that format, and they also show the data in that format. And actually these relational databases, they eventually keep data on hard drive files, on the hard disk files. And if you consider the Excel, the row and column, you can see the data are actually is kept and can be kept in the row wise format even in the hard drive. I think what can happen, one row of data, just put one cell by cell, and when it goes to the next row, put some ending mark. And then I think in hard drive there are sequential storage spaces, right? So you can just put one cell by one cell, but when it comes to the next row, you just put a special mark so that you understand that it's the next row that's starting. So yeah, I think Access, SQL Server, Oracle, they are relational database management systems, and I think each of those different domain data, they will have some identity information, and one file or one table will be related to another table using those corresponding ID. Let me read this slide and see what I wrote here. Why they keep data in files? Yeah, kind of. They keep data organized for sure, table format, row column wise, and there are some field and the corresponding value, and for the corresponding identity, yeah, data in different files and tables are related, identity column field. And RDBMS, they will also give you the tools to sort the data, search the data, do some calculation on top of the data. They also provide some programming language like SQL to retrieve the data easily and to operate on those data easily. Okay, and now relational database, they also have some additional features they maintain, like atomicity. SE properties: atomicity, consistency, isolation, and durability. Atomicity, what does it mean? I think when, let's say, you are using a relational database for a banking system, what will happen in the database management system? It needs to, I think these features are required because if a business uses those RDBMS, without these features, the business operations or the customer expectations, those cannot be met. I think in real life, the way the business wants to operate, or all the functionalities, transactions, they will be happening day after day, and all the data changes, they will be required. Data changes or the consistency or integrity of this database they want to maintain. They need these asset properties on the database management system software, otherwise the business processes, the business will not function as desired, the customer expectations will not be met as well. So without these features, RDMS will not provide much value to the business or to the customer. So atomicity, what does it mean? I think atomicity, it does the transaction. Transaction is just one set of operation that has to be executed at one operation. Either all of them has to be executed, or none of the effect of individual operation can be there. So it has to be all or nothing. Let's say if a transaction has 10 different operations, so if it breaks after 5 operation, the system crash or whatever happens. So what has happened in the first 5 operations, whatever was changed, that has to be reverted back to the original state, because 5 operations are left, those are not executed, so we cannot accept those partial changes. So either all of 10 operations has to be applied, or none of the effect will be there. And there are mechanisms to RDBMS implement some backend operations that will maintain this. So I think transferring balance from one account to another, there are some couple of operations involved, right? Access the account, debit it from the first account, access the second account, put the value into the second account. So those are the things. But if it happens that the operation breaks after you withdraw the money from the first account and it breaks, then the system becomes the transaction is not complete, right? The transaction is not complete, so the system has to give the money back to the first account. And also, when the system breaks, the system becomes inconsistent. But we have to do for what the relational database that also needs to maintain the consistency. What does it mean is that I think any transaction should take the database from one consistent state to another consistent state. I think breaking the database in the middle of the transaction will keep the database in inconsistent state. So isolation, I think concurrent operations in database management system need to be handled in such a way so that it feels like they were executed sequentially. I think, let's say, if you are transferring money to your friend's account and your friend is transferring money to your account, forget about bottleneck or deadlock. Just say that those operations are supposed to be successful. In that case, if for these concurrent operations, it has to happen, and after the both operation, the system has to be inconsistent state. I think you will need to see the effect of your transaction and your friend's transaction. Your friend also need to see the effect of your transaction and his transaction, and probably you are trying to do the at the same time. What will happen is, I think the computer can act very fast, right? Whenever you or your friend is doing those transactions internally, all the subdivided works, the computer will arrange them in such a way so that nothing is badly affected. All of the operations are there, and everything after that operation, everything will seem like a consistent state. Durability, once a transaction is complete, the effect should stay there. It should not just should not get badly affected. Let's say the transaction is complete and you and your friend did not do any transaction in between for a 1 month or 5 months, then the today's state should also be there after 5 months. So that's the durability concept. Okay, I hope that you got some understanding what a relational database management system is. And if you have further question, comment in the comment, and then we might get back to you. And if you think that this information might be useful to someone, you can also forward this information. Feel free to share in your blog or Facebook, social media. Feel free to share. Thank you very much. Have a good night. Bye.